16th October 2023. According to this article published in Popular Mechanics, scientists have found cracks in the universe. And not only this, but on many websites like Life Science Space. The same articles have been published, which is the reason for this picture of twin quasars discovered in 1979, which we know as QSO0957 plus 561A and QSO0957 plus 561B. Their size is identical and they are very close to each other. Now, the brightness and spectrum of these two quasars are also very similar. The scientists noticed that these two quasars were emitting the same type of emission at the same time. And it is not for a few seconds or minutes, but during the observation of 100 days, it is seen continuously. On 22nd September 2023, in the European Physical Journal, the reason behind the twin quasars is the gravitational lensing caused by the cosmic string. But what is this cosmic string? And how its discovery is going to change our view of the universe? Well, friends, the cosmic string is a very big puzzle for modern cosmology. Can you imagine it as a crack in the universe? Yes, there are cracks in our universe. And this was first said by British theoretical physicist Tom Keeble in the 1970s. And something similar happened during the formation of our universe. 1380 crore years ago, when the Big Bang didn't happen, the whole material of the universe was in a singularity, in which the density of plasma was infinite. Along with this singularity, the heat concentration and its temperature were also touching unimaginable boundaries. Now friends, as soon as the Big Bang explosion happens in the universe, this plasma of infinite density expands and its heat concentration also decreases. After 10 to the power of minus 36 seconds of the Big Bang, the rate of expansion suddenly increases. And then after 10 to the power of minus 32 seconds, it becomes very slow. The sudden break on the expansion and the continuously decreasing heat concentration results in a phase transition here, and cosmic strings were also formed during this phase transition. Now, to explain it in simple terms, the changing conditions of the early universe gave birth to some cracks in it, just like water comes into ice when it freezes. Cosmic strings are like large threads spread in the universe, which can be larger than galaxies. These are one-dimensional structures made of pure energy and their thickness. When NASA's Cosmic Background Explorer mission was sent to space in 1989, and it made an all-sky map of the CMB, that is, the cosmic microwave background, then the CMB features were seen denying the existence of the cosmic string. However, quantum field theory and string theory both approve the theory of the cosmic string. Now friends, you must already know about string theory. Reality is made up of tiny vibrating strings, not subatomic particles. String theorists believe that in some certain conditions, the tiny strings of string theory become so big that they can be spread to galaxies. Due to its high energy density, a cosmic string behaves like a gravitational lens. And because it is a one-dimensional object, it takes out the exact photocopies of its surrounding objects, as we saw in the case of twin quasars. And this work has been done by a team of physicists from India and Russia, whose research paper was published in the Astrophysical Journal on 21st September 2023. For this research, data collected by the Planck satellite has been used, which was sent to space by the European Space Agency for cosmic microwave background analysis in 2009. Along with this, the Himalayan Chandra telescope in Ladakh was also taken for help. Now, during their studies, they discovered a pair of two galaxies millions of light years away from the Earth, which are named SDSS J110429A and SDSS J110429A B. And since this is our first potential candidate for the discovery of the cosmic string during this research, it is called CSC1, i.e. Cosmic String Candidate 1. Both these galaxies are very close to each other and both have exactly the same shape. Normally, when gravitational lensing is done, the shape of duplicate galaxies looks a little distorted. But none of these galaxies have a distorted shape. Now, let's compare the spectrum of these two galaxies. Both the spectrums on the screen look very similar. Now, they are not 100% similar, but there is not much difference between them that we can assume them as two different objects. Now, the light coming from both of them is also being received at the same time, and we do not see any difference in it. So, is there a cosmic string here that is making a mirror image of the same galaxy? Well, friends, if a cosmic string is doing gravitational lensing of an object, then we should get to see a definite symmetry between our two objects. So, can we say that we humans have succeeded in discovering the cosmic string? Well, the answer to this is yes and no. And to be honest, the answer is not that it is too heavy. It is normal to get the same type of lakhs and crores of objects in the universe, but the same looking objects can't be technically possible. In such a case, when we look at the example of twin galaxies in the twin quasars or in this research paper, then there is definitely some miracle of a physicist hidden here. Now, CSC1 certainly fulfills the conditions of gravitational lensing by cosmic string. But here the problem is seen when we compare the writers of both the research papers. Look, the Russian writers of both these research papers, it is exactly the same. It means that they have given a theory in one paper and they are also justifying their claims on the basis of their own theory in the other paper. Now look, what I mean to say is not that these research papers are wrong or false. The point here is that these two research papers are at their initial stages, and before the scientific community does deep research on these claims, we cannot reach any conclusion. On the other hand, it is not necessary that these two galaxies are mirror images of the same galaxy. It is also possible that the galaxies here are about to collide with each other, and this is a rare phenomenon of galactic collision, which we are still unaware of. Generally, scientific research papers are very lengthy and highly researched. But this research paper, published on 21st September 2023, is only 6 pages long. Also, no solid evidence has been presented about the existence of cosmic strings. In short, we can consider it a positive step towards the discovery of the hypothetical cosmic string. But my friend, the way to actual discovery is still quite long. But now the question arises, why is the cosmic string such a complicated puzzle for us humans? And what will be the benefit of solving this puzzle? Well, friends, the puzzle of cosmic string is made so complicated by its size and thickness. See, in a distant space where we do not see the stars spread over millions of kilometers, how can cosmic string with a thickness of less than 1 nanometer be detected? Now see, we have already known that according to scientists, cosmic string makes a mirror image of the object around it. But in the history of space exploration, we have not yet discovered so many identical objects that we can further analyze the theory of cosmic string by studying them. And the discoveries that have been made can be seen in addition to the theory of cosmic string with other phenomena. But friends, as I always say, there is no end to human curiosity. Our search for cosmic string is going to continue. What do you think? Will something like cosmic string really exist? Or will it remain as an imaginary thing forever? Do let us know in the comment section below. If you like this video, then don't forget to like it. I will meet you with the next episode. Till then, bye.